So now let me take you through the algorithm and the code of binary search. Okay, so the algorithm goes like this. Step 1, start, take input array and target. Target means what you want to search, the search number basically. Okay, target means the search number, the element which you want to search, number or character or whatever. Okay, now so start or end, you can say starting point, end point. So let's say if this is an array, okay, so you have let's say 0 1 2 3 4 5 6, you have basically seven elements. So start is this, starting point you can say sp or start, whatever, and your end point is this ep, end point. Array size -1, 7 -1 6, that's the last one, right? So that you initialize, and then there will be a midpoint or a mid variable which is mp, which is equal to nothing but sp plus ep divided by 2, right? That makes sense. So 0 plus 6 divided by 2 will be 3, so this is your midpoint. Don't worry about odd even numbers in the array, it will be taken care of by the algorithm, so no need to worry about that. It will ultimately find your array, find your element in the array if it exists, for sure. Okay, the algorithm is automatically made like that. So that is so now you have a starting point, you have a end point, then you have a midpoint which will take care of your midpoint every time you have a new array to search, because you will be dividing it into half and then you will only take the left side or the right side, right? Then then what you do, you have the midpoint with you, then you say, let's say the array name is a, so you have to check whether your a mid is equal to your target or not, right? That you have to check. If it's target, then return mid means right now just you can ignore the return part here, it's just a way of writing another algorithm with function. You have a function of searching made here, but you can just avoid to simplify, you can simply say that if a mid is equal to target, then of course you say the element is found and you exit the loop or your algorithm, right? And if it's not, then if you have to see whether this is less than, so a mid is less than the target, means the target is more than the a mid, and you have to remember that it's a sorted array, it's a sorted array. Okay, so if your target or the search number is more than the a mid, the midpoint, that means you have to go to the right side. The right side will be your new array, right? You have to go to the right side. I'll tell what is this. And if it's less, means the array mid is more than the target, or the target is less than the midpoint, then you have to go to the left side, right? And this is left. Okay, and till the time your starting point is less than midpoint. So the starting point will always be less than the end point, sorry, not mid. So if the starting point is still less than the end point, means you are still not reached the ultimate one element array, then till that time you have to continue it. Okay, if your element is not found, somewhere you will have a flag here. If that is not if flag is still false, then you just say that target not found, or the midpoint or the search element is not present. All right, now let me just come to this part. So if so let's say if this is your array, and so 0 1 2 3 4 5 6. Okay, I'll just cut out this one. Okay, so now in the beginning your sp is 0, your ep is 6, and your mp is, and mp means midpoint, 0 plus 6 divided by 2, which is 3. Okay, now in case if you get your element at this, then you just exit the loop, your element is found. If it's not, let's say if the target or the search value is less than this, okay, if your A mid is less than your target, right? That means it falls in the left array, right? The left side of the array. So now your new array will become the left side will become the new array, right? So now you have to search in this using the same technique. So now what will change if you have to, this will not be touched in that case. Only the left part will be touched. So you have to only take care of 0, 1, 2 in this case, right? So what will be your starting point? Starting point still is 0 only, but your ending point will change, correct? What will ending point? Ending point will be just one element before the mid one. So your ending point becomes MP minus 1, right? Makes sense? So your left array now is a new array to be searched using the same technique, and in that case only your end point of that mid array the left side array will change, which will be your midpoint minus 1, because the midpoint will just before the midpoint your array will end, right? So this is your new array to be searched. Now if the case is the other way, you have your A mid more than the target. One second, I think I missed here. This should be target. One second. Your target is more than the image, so it will be actually in the right array, or we can just make it like this. Let's just just make it like this, and yeah. So if your target is more than the midpoint, that means it falls in the right array. Okay, it falls in the right array, so it will be over here. So in that case, what will be your new array search starting point? Starting point will be changing, right? Because you have to start from 4. Okay, but end point will remain the same. It will be the same only, whatever it was previously. Okay, so your starting point will become what? Midpoint plus 1. Okay, that's the only thing you have to do. So you can see in this code over here. So this is your initialization. Starting mein you can keep all of them as the starting point and midpoint as 0, or even if not, then it's okay if you don't define if you don't declare initialize the midpoint. So this is your array. Now your search or the target is this. Now endpoint is nothing but x dot length minus 1. Okay, because that's the last index you have to take. Then you have a flag here which is false in the beginning, which will take care of if the element is found, then you have to make it true, and then you check at the end by if condition. So your while loop, you can here use a while loop instead of for loop. It will be run till your starting point is less than or equal to ending point. Okay, I'll explain that also why it is like that. So while starting point is less than or equal to ending point, you have to follow the loop, follow the algorithm. So what is MP? MP is nothing but endpoint plus starting point divided by 2, or EP plus SP plus EP divided by 2, doesn't matter however you do it. So that is a midpoint. Now you have to select the element at the midpoint and check whether it's equal to your search element or not. Okay, if it's yes, then you just say term found at this, and your found is equal to true. Make your flag is equal to true, and you break the loop. Okay, and why? So if it's here, if it's if it's true, then you break the loop, and here it will come the control, but then here the found is not false, it's true, so it will not print this, but just print this, and your program is done. Okay, why we are making a flag, using a flag here? So that you don't go on searching for the whole array even if you have found it. There's no point of going to the whole array if you have found it at the first or second place in the first or second iteration only. And why you have to go till the end, do all the iterations, just increasing your time complexity. So you have to just do found is equal to true and break the loop. Okay, if it's not found at the midpoint, then what you do, you have to just make take the you have to decide whether you have to go to the left side or right side. So if the midpoint, the array element at the midpoint is less than the target, then you go to the left side, right? That is the left side, the left array, and then you change your if your search element is more than the midpoint, which means that since it's a sorted array in ascending order, so it lies in the right side, so this will be the right array, right? This will be the right array, and your starting point will change to MP plus 1, else it is the left array and you go to the left side, and that will change only your ending point. Okay, so yeah, and if nothing happens in this whole loop, in the while loop, if even once if your target is not found, then if your flag found will always be false. So in this case you can just check it out, that found is still false, that means the term is not found. Okay, now let me just tell you what is this, why we are doing this. So now what happens is you take this array again, you let's say your element is not at middle point, not at 3 also, then let's say if it's lesser, then it's somewhere in the in the mid in over here. So now your new array is at 0 1 2, so your middle point will be 0 plus 2 divided by 2, which is 0 plus 2 divided by 2, which is equal to 1, right? So you will now have 0 1 2 and you check the midpoint here. Okay, if it's not, if still it's not found, and let's say it's in the left half, in this half, then your what will happen in the left, what changes? SP remains same, only your EP changes. What is EP? EP is midpoint minus 1, which is again 0, right? Earlier your midpoint was 1 like this and you didn't find it, it's still lesser, the element is still lesser, so it is in the left half, correct? So your EP changes, EP becomes MP minus 1, so 1 minus 1 is 0. Now in this case SP is 0, EP also 0, and the midpoint will also be 0 only, right? So this is, so it will check at this point, and it has to find out or it cannot find, suppose. So it doesn't matter, but that's where your search will end, right? Because that means if you find it, then well and good. If you don't find it, then you have to end your search, because then there's nothing left, because it was not in the right half, it was in the left half. So still if it's not found, that means the array was still small, the search element was still smaller, and it is not in the array at all. So this is where your search should end. That's why the condition is like this, that your SP, while SP is less than or equal to the end point. It cannot be more than, starting point cannot be more than the end point, right? Because it's a sequential array. Okay, so hope the binary search is clear.